Today I shall consider another sufficiently complete systems. Last time we considered the system HO accompanying system is Boolean functions is now let us consider some properties. These are functions. These functions, if you remember, have properties about which I take your time on the first lecture. Here, from these properties, only such are true. On this form. This operation, non-associative, non-distributive, according to one another, so poor system of properties. But these functions are functions continuous arguments, so functions such kind some additional properties. Then and only then. I once meet in English paper to n instead to write then and only then. So I shall write then.
This is very strange. You write if and only if, IFF.
We say if and only if.
Yes. Maybe I meet then and only then. Then.
Could be another.
Yes, maybe. If. It is shorter. It is good. If x is 0 or y is 0, x more y equals 0. X if x so if I shall make such drawing, air conjunctions is 0 only on this sides. Disjunctions, here is plus. Disjunction here, plus, minus. This is main properties, these functions. Besides, these functions have jumping of derivatives in point O here. Jumping, we can, if you write it in polar system, we receive so if we shall take derivatives in any direction, the and so on different directions we shall have another different results. But jumping here will be finite.
What is the definition of this function when
I only use polar system coordinate, and after I put instead x and y this expression, I receive such formula, and then when I take derivatives along minus r in any direction, I receive such expression. And it is, if this is phi, then result will be different for different phi. The result depends on phi. Yes? So we have jumping. Разрыв, как сказать по-английски. Discontinuous. So in this point, these functions are discontinuous. This defect behavior functions is from system HO. It is easy to repair. And we, for example, we can take such system This is the name this system. In that case, if we transform into polar coordinate, we shall have and when we shall take derivatives on this direction, we shall have 0 until derivatives of the m. Yes? So this system is more comfortable for using in many cases, but in some situation this system is preferred, and this system is the most using now. Then in future I explain why the system is better than this system in, for example, when constructing solving boundary value problems. Another generalization of this system is very simple system This is, so are conjunctions, are disjunctions. So this system now is seldom using, but for this system it is easy to prove the property, the theorem. Suppose some functions which belong n minus 1 have n minus 1 derivatives. Then if L is some differential operator, this well-known symbol, then name this system.
Yes, but
M index is given N. What should I say?
M.
Equaling N.
Of course, M. Or
Equaling
easier,
N.
easier to
N.
define, change
N was that.
the, okay. And now what about the K? The K?
yes, yes. Okay. Such notions. These symbols very useful, so I hope you get it. This theorem led us to use this operator for such complex expressions in some situation.
This holds for all M.
K is less than N. Of course, this system H2 is H0. We receive this system, and so for derivatives of four linear operators less than 2, we receive such formula. For example, d for dl This is very useful formulas. L, any direction in any point, in any direction in any point. Now, let us consider one more generalization system, system HO, H alpha. This is radical. This is a conjunction. It is easy to prove that this is a conjunction if we consider some parallelogram. Suppose this side is x, this y, model y. Then consider diagonals and alpha. Alpha here in this formula can be any functions. So with such inequalities, any functions even according to any of arguments and symmetrical. Suppose cosine theta is equal alpha or minus alpha. Then one of these sides will be, according to cosine's theorem, will be equal this radical. And suppose x and y are positive, then sum of sides will be more than diagonal. Those are the same. If one of these arguments is negative, then we have this destruction of the sides, and it will be less than those or those. So even if x negative, y positive, then one of these diagonals will be equal to this radical, and subtraction will be less than this radical, and we result have negative result. And of course, if x and y are negative, we have results negative. So in that case too, we should have plus on the x and y positive, and minus in other cases. For this disjunction, we have the same, like in some situation, it is very useful to take into consideration that alpha is function, and it led us to, for example, when we consider some special points where we must to create any additional behavior function in special points. Due to these functions, we can construct some behavior we wanted. For this system, it is true the theorems. X this formula gives us result less than smallest from this.
That is the reason why we have one. That is the reason why we have a factor.
That, yes. You saw that this factor don't influence on signs of the what. But due to this argument, one of the theorems will be true. This factor influence on some another differential kind of property, not logical. Are functions connected in itself some properties logical character and some properties differential character. So we make play on these possibilities. It is easy to, for example, x less than y. Then we can rewrite such formula: x plus alpha x plus phi minus alpha x minus, and here is the same. I rewrite this expression in that form. Then this is less than this. So we have, if I note it some minus delta quadrat, minus delta square, negative expression, then we shall have minus this is x. After x minus some quantity give us quantity bigger. In the same way, we can prove that such expression more than maximum. Disjunction gives us more than. For example, if I take some functions suppose t is time, there are some signals which depend upon time. For example, sigma 1, sigma 2, and sigma 3. Then, if we shall use symbols, for example, sigma 1, alpha, any formula in which we use symbols operation, then we knew on that here is interval where sigma 1, 2. Here we shall have result less than sigma 1 and 2. So some here, but more than sigma 3. So example result will be somewhere here. In that position, we shall have less than this interval, but more than this. So will be such behavior. here less than this, but more than this. So on. Here less than sigma 3, or more than sigma 3. So I don't want to do such construction, but we can make, let us more simple example, only two functions. Suppose one function and another. And without this term. Then we shall have functions. It will be functions which is less than 1 and less than 2. So such kind will have trajectories. Then if we add sigma 3, for example, we must consider here will be more than this signal. But three. Somewhere here, yes? Oh. Maybe так. Maybe I did not the mistake. There are some problems where such treatment can be useful. Now, one more result according to the system. For this system is also to result such kind for derivatives first order. So and we, in any situation, can use such penetrating differential operator inside this formula. And another result, if suppose these functions according to any direction have derivative second order negative. So functions, if for example there are functions two arguments, they have vertex surfaces. Convex surfaces, yes. Then, in that case, also 0. If I shall try to write this proof, it will come by some formulas. And At last, here another systems. This system were constructed for different problems. Oh, before I tell of these formulas, I must to say that if I consider such expression, this formula is formula which use Ricci for this junction. There are a lot of papers. Vadim Shapiro collected a lot of papers which use R functions and functions, Ricci functions. Difference between Ricci functions and R functions, you can see. Yes. And one of his functions, Ricci, next system is polynomial spline system. Only here plus. Here n plus 1. It is easy to see that signum, if consider signum such kind, x plus 1 divided x plus 1, use such kind formula, is approximately, this give signum where this is 0 in denominator is not 0, but here is a factor which is 0, and after, for example, n is 2. Then we shall have because here is said order signum is we can write in such way. Minus x minus 2. But here, second order and signum is 1. After, we shall have such simple formula. Here, derivatives have discontinuities when x plus 1 is 0. So, only one line discontinuous derivatives. Functions positive. So this is conjunctions, but line where derivative is continuous. When we shall use for any polynomials such operation, we shall receive polynomial spline. Here is, these functions are belong to the n Cn and time have n derivatives. And we shall use, and so disjunction for polynomials. We shall receive polynomial splines with some lines which we ahead don't know, but we shall polynomial splines surface which is a piece polynomial and smooth. Nobody uses this function in practice, but some fact is interesting, it seems me. And at last, all these systems which we consider, but one of system when alpha is 1, we have system one plus alpha is. If we put here instead alpha 1, then we can take radical and we receive and it is exactly so this calculation lead to and in this system maximum. This operation are not only associative, but also all properties are satisfied, but x all other properties are the same like in Boolean functions. But this system
Only for alpha equal 1, right? Only for this system. Only here. 1 for 19. Это держится только для этой системы, правильно?
yes,
Но я просто спрашиваю, только для этой, для других альфа нет.
yes, yes, only if alpha is equal 1, then all these properties are true. But without these two. But this system is not good when we must to have derivatives, because x, the line where discontinuity derivatives, even first order. So in mathematical physics, when we mostly, I and my people working, we can use this system. But in some situations, for example, Professor Stoyan cutting the problem of, for example, we have some pieces for suit, and we must to replace it here in such way that to cut smallest distance. Such kind of problems, this operation can be used, and they are using. Place this, some plate figures or some space bodies in any space for optimization. These functions are using. Now I show you last one system, which is associative and have other good properties, but is complex inside. So in here, take this formula, here x, y, and this formula. These functions belong Cn outside of, out of point 0, are n times derivatives, and this function is associative. And for this system is true theorem when we use operator LK. But it is difficult to use such formulas for disjunction. Disjunction we can define due to This construction, all kinds of this construction we're using in our practice. But it is easy to see that if we have not associative functions, then is some problem, and because of it appear the attempt to construct it not binary operation, but ternar or NR operation, which have such kind accompanying Boolean functions. For example, for n3, it were constructed such formula: x, and it was proved that this is positive if for this positive, and if one of them is negative, then this is negative. And this for 3 and for n, it was for 3 and for 4, it was such inequality was proved. But in general case, for any n, there is not proof till now. Nobody knew how to prove if we have is then here x the minus so on.
You don't know that. You don't know if this is true.
I write it in another form. Here we take all elections and two minus. 2. Here we take 3 of them different, this plus, so on. At last, I don't know what here say. Such combination. But in general case, I don't know how to prove, and if I understand, nobody knew how to prove these inequalities. This is
How hard have people tried?
how much people try.
Yeah.
Yes, in Kharkov, I many times explained this problem for mathematicians in Kiev, in Moscow. About 30 years.
Is there a prize?
I don't know.
Награда есть?
Что?
Спрашивают, награда есть?
Nobody. But it seemed for me that this problem have fundamental значение, fundamental meaning for Euclidean space. I shall explain this thought. If you take, for example, n2, and suppose we take rectangular, this is x and y. This is diagonals. Let us call sides of the rectangular diagonals zero order. Diagonal zero. Here is diagonals first order. Then we can say that sum of all diagonals even order more than sum of all diagonals odd order. Indeed, 2x plus 2y minus 2 diagonals more than 0, and we receive functions that kind. If you take parallelepiped, sides, diagonals, zero order. The diagonals of face, diagonals of face, second order, and diagonals of cube, this parallelepiped, third order. And we have 4x plus 4y plus 4z minus 4 diagonals, 4 plus 4 more than 0. It was this inequality was proved. So on. But this is fundamental property of the two-dimensional space. So we can suppose that this is fundamental property of ES3. So on. If once I took all sides equal unity and some number inequality and plus C is n for 2 plus such expression. And this is some functions n, and I consider by computer what this is the dependence. And if take n, Fn, this is functions go to 0, so any further inequalities is missing. And I suppose that in general case is very, very difficult problem. Thank you very much for your attention.
Can you tell us what's going to be next time? Что следующий раз?
Next time, I suppose to begin to show how our functions can be used for inverse problem of analytical geometry.